So we're going to calculate the class practice 19.7. First of all, in this question, I just highlighted the important details of the question. We have 25 cm cube, non-concentration sodium hydroxide solution, and it was neutralized by 30 cm cube of the solution of diabasic acid. So it means that in your brain, again, you need to have such diagram. In the burette, so in this time, we have the diabasic acid, okay, H2X with unknown concentration, right? Because we are going to calculate concentration. And in the conical phase, we will have the 0.12 m, 25 cm cube sodium hydroxide solution. And we do the titration in order to determine the concentration of the acid. So before we calculate the everything, first of all, I'll write down the chemical equation again. So we have the acid, diabasic acid, and sodium hydroxide, and we will form, since we have H2X, so X should be carried negative charge, right? So we will form this salt and then H2O and balance the equation, and we will have such chemical equation. So the mole ratio will be 1 to 1, 1 to 2 ratio. One acid react with 2 HCl. So first of all, we know how many number of moles of sodium hydroxide in 25 cm cube, right? Because we have the volume and also the molarity, and we will know about the mole of NaOH, okay, in 25 cm cube. That is 0.12 m times the volume, okay, and we will get the number of mole. So we do the calculation with the calculator, and you will get 3 times 10 to the power of negative 3. That is the number of mole of sodium hydroxide. It means that from the acid used, we have used up 30 cm cube of the acid, right? So it means that in 30 cm cube, we also have 3 times 10 to the power of negative 3 moles of acid. Sorry, not 3 times 10 to the power of negative 3 mole, because it's 1 to 2 ratio. In 30 cm cube, how many number of mole of acid inside here? So because we have reacted 3 times 10 to the power of negative 3 moles of sodium hydroxide, it means that inside 30 cm cube, we will have 3 times 10 to the power of negative 3 and divided by 2, because the mole ratio is 1 to 2. So you will get 1.5 times 10 to the power of negative 3 moles of HCl in 30 cm cube. So based on this information, now you're asked to calculate the molarity of the acid. We know the volume, we know the number of mole, not HCl, sorry, should be the H2X. We know about the volume, we know about the number of mole, so we will know about the molarity. And molarity of H2X then will be 1.5 times 10 to the power of negative 3 divided by 30 divided by 1000, because it is a volume and it is the number of mole. And simply do the calculation with the calculator again, and you get 0.05 m. So the solution will be 0.05 m. So the second question asks you to calculate is the molar mass of the acid. So based on the information, so at the beginning, okay, for B part, the concentration is tell you that in 1 gram, in 1 dm cube, we will have 6.3 gram, right? Okay. That means in 1 dm cube, we have 6.3 gram of the H2X, right? And in part A, we calculate that in 1 dm cube, or I say, all right, in this way. So, and the other concentration we calculate in part A will be 0.05 mole per dm cube, right? It means that in 1 dm cube, we will have 0.05 mole of H2X, right? So just let now we have the volume, let us as a 1 dm cube. In 1 dm cube, we have 6.3 gram. In 1 dm cube, we have 0.05 mole. So can we, based on this information provided to you to calculate the molar mass? Should be yes, right? So how can we calculate? Let's say we have 6.3 grams, and in 6.3 gram, we will one dm cube will have 6.3 gram, right? In 1 dm cube, we will have 0.05 mole, right? It means that in 6.3 gram, we will have 0.05 mole, right? So we have the mass, and we also have the number of mole. So we can calculate by dividing 6.3 by 0.05, and you will get 126 as the molar mass. That's the answer of B part. So let's continue to question 2. Okay, now we have 3.44. Okay, 3.44 unknown metal carbonate, and it dissolved in water and made up to 250 cm cube. It means that for volumetric fast, 25 cm cube of solution withdrawn by pipette and required 33.2 cm cube of 0.15 m hydrochloric acid. And you're asked to calculate the molar mass and then the relative atomic mass. So how can we calculate it? It's very simple indeed. First of all, again, this diagram. So in the direct, we have put the HCl, and the chemical fast, we have put the 25 cm cube of the M2CO3 solution, right? And afterwards, we write down the chemical formula. Yeah, with HCl, and you will get MCl and also CO2 and also H2O. So that is the chemical formula, and we balance the chemical formula, and you will get something like this. So 1:2 ratio, it means that one metal carbonate will react with 2 hydrochloric acid. Okay, so now we have reacted 33.2 cm cube of 0.15 m hydrochloric acid, and we can determine the moles of HCl reacted by 0.15 times the 33.2 divided by 1000, and you will get the number of mole of HCl reacted, and you will get 4.98 times 10 to the power of -3, right? And afterwards, when we know we have reacted 4.98 times 10 to the power of -3, we will also know the number of mole of M2CO3 in 25 cm cube, right? The moles of M2CO3 in 25 cm cube, okay, then will be 4.98 times 10 to the power of -3 divided by 2. So divide by 2, and you will get 2.49 times 10 to the power of -3. In 25 cm cube, we have 2.49 times 10 to the power of -3 moles of M2CO3. So it means that in 250 cm cube, okay, we need times 10, right? Okay, you will get 0.0249 moles of metal carbonate inside 250 cm cube. So we get the number of mole. Okay, finally, we have the mass, right? Can we calculate the molar mass? Should be yes, right? molar mass, okay, divided by, determined by the mass divided by the mole. So mass will be 3.44, mole will be 0.0249, and 3.44 divided by 0.0249, and you can get 138.15 will be the molar mass of the metal carbonate, N2CO3. That is A part. And B part is ask you to calculate the relative atomic mass of M, right? So we have the molar mass. Simply use the molar mass of the compound and subtract minus the carbonate. And then we have 2 in one compound. So we divide overall by 2. So finally, M, the relative atomic mass of M will be 39.075. So refer to the periodic table, you will get M will be equal to potassium. So it will be the potassium carbonate. That is the calculation here.